Okay, so I'm about to go over part 2 of the Xfoil project. So in part 2, we focus more on the Clark W airfoil specifically, and we're looking at it over viscous flow, Reynolds number 300,000, and Reynolds number of 1 million, again with the alpha varying from -5 to 15 increments of 1. So I'll get into that. In my previous video for part 1, I kind of went over how I got my Clark W airfoil. Here are my points again. Again, it started as 34 points, but after changing the node count in Xfoil and saving it, it changed it to many, many more nodes. But same airfoil. Here we have the program. Load Clark W. So for the very first one, we're looking over viscous laminar flow on our Clark W airfoil. So we'll go to, well, let me make sure everything's looking good. My PPAR. Okay, that's better. So going to operations. Usually we have to change it to viscous, but not here. Oh, yeah, because I meant to say inviscid, then Reynolds number 300,000, Reynolds number of 1 million. So we're looking at inviscid first, so we're not changing it from inviscid. I'm going to change the iteration count to 100. It might not be necessary because it's inviscid, but we just look at our sequencing. Go from -5 to 15 by 1. Load that up, and it loads instantly. I mean, it's inviscid. It looks nice. It's the same deal as before, where I just save it and then I open it up in Excel. I can do that again here. I'll just say inviscid, initialize it, and then sequence. Same thing happened. Let's see. Then I'll look at. There we go. Just looking at the text file for it. Everything's looking as it should. All this. Same thing I was going over before. I will just open it up here in Excel. Next, finish. Here we have the inviscid. Now I'm going to do the same for the next two parts of this part of the project. So I'll close out this, close out inviscid, reopen it. Okay, now we're looking at it with a Reynolds number of 300,000. Okay, so go ahead and get all this set up to begin with. Operations, set it to viscous. 300,000. Gonna want to get 100 iterations. Let's just make sure it's looking okay. Here we have it. Gives us everything. I'll save it to a file. Just call it RE3 for 300,000. Okay, let's see what it's looking like. Put it in a notepad. Okay, as you can see, we have all of our things here. Gonna minimize that, exit out of this. Same deal, just opening it. This, open it there. Yes, next, finish. And then the convenient part about part 2 is the last Clark W Reynolds number we look at is at 1 million, which I already found in this first part, so I'm not really going to go over it again because I've already gone over it, but I just use the exact same data I got from here for the part 2. So it's all the same information. But here's my put together already spreadsheet for everything. We have our unvisited, Reynolds number 300,000, Reynolds number of 1 million. Let's see, it's asking for CL max, CD min, performance versus alpha. So as you can see, I have them on my graphs here. And then for the tables, I'll go to my Word document. As you can see, part 2, the same graphs here. Here I have my table, I'm looking at the max lift, where the max lift is, minimum drag, where it's at. As you can see, for the Invisid, the minimum drag is 0. So, it's 0 for every single angle of attack as well. And if you divide something by 0, it's going to be more or less infinity. So that's why I put this here. Now my discussion right here, as it asked for in the project. But I believe that's about it for that. More or less, we were just looking at the different Reynolds number for our Clark W airfoil. But yep, that should be it for part 2.